Hello, everyone. I am Matsuura, and I'm in charge of research and development of the database layer in the service platform division of Yahoo Japan. Thank you very much for taking your valuable time with us to attend this session. In this session, I will talk about the joint R&D on building a MySQL storage engine for the latest hardware, which is being jointly conducted by Yahoo Japan and Line, and the research and development of unique storage engine for MySQL to effectively utilize the latest hardware. Here is the agenda of this presentation. First, I will talk about the theme of Unleash the Power of Data, which is the motivation for our joint research and development. Following after that, I will talk about the latest hardware technologies that we are focusing on, a new landscape for unlocking the power of data. Thirdly, I'd like to talk about Game Has Just Begun, which is a joint project between Yahoo Japan and Line to effectively utilize the latest hardware technology that we are focusing on. And I'd like to talk about our proprietary MySQL Storage Engine. Lastly, I will wrap up Just Go and Game Continues, and I will talk about the future direction of our joint R&D efforts. First of all, I would like to talk about the motivation of a joint R&D and list the power of data. Data empowers people, and people empowers data. And the data supports activities of people, and the people's activity generate valuable data. And the activities such as get to know or to buy and to be connected and to enjoy are all supported by data. For instance, on internet, if you want to buy something, product information is stored as data in database. And also, if you want to enjoy music on the internet, music data, where is the music data stored? It is stored as data in database. Yahoo Japan and Line contributes to the activities of people getting information, purchasing, connecting, and also to enjoy in order to enrich the power of data. And we offer various services. These services are further improved based on the feedback data from users to polish them into even better services. Next, I will talk about the need for good data platform to provide good internet service. To deliver good internet services to users, we need a fast and stable data platform. A slow data platform requires time to search for product data, which worsens the user experiences, and also unstable data platforms can cause problems when users cannot find data when they need. With a good data platform, the experience of fast, comfortable, and secure internet services become possible. Now, let's dig a little deeper into what constitutes a good data platform. There are many requirements for good data platform. Today, I would like to focus on three of them. First is performance, the ability to process large amount of data and access large amount of data at high speed. This means that user will not experience any stress from slow operation, and the service will be comfortable to use. Second is never stops or stability. Many internet services are based on data platform. If the data platform stops working, the internet services that use it will also stop working, and users will not be able to get information or use the services where they want to. It will be a serious problem. To prevent this from happening, stability is one of the prerequisites for good data platform. Third, scalability. Internet services must constantly evolve and expand in response to people's needs and change in society. A good data platform must be able to flexibly respond to such evolution and expansion, as well as to increase in data volume and number of accesses. Yahoo Japan and Line already have fast, stable, and scalable data platforms in production. However, in March 2021, Yahoo Japan and Jet Holdings and Line announced their business integration, and the two companies will work together to create even better services. Therefore, it is expected that collaboration between the services of the two companies will deepen in the future in areas such as pickup and drop-off of customers, and the database workload will further increase. This has necessitated an evolution of our data platform to make it faster, more stable, and most scalable. We need to evolve them. And with the aim of creating such a new data platform, we have started this joint R&D from 2022. Next, I would like to talk about new landscape and hardware technology that we are focusing on creating faster, more stable, and more scalable data platform. There are three main new hardware technology that we are focusing on. First is memory pooling technology based on non-volatile memory, Compute Express Link, and CLX, which changes the database storage hierarchy. The second is RDMA, RockKey, high-speed network technologies. Thirdly, a storage solution that supports new storage hierarchies and devices. In the following slides, I will give an overview of the three new hardware technologies. First, let's take a look at one of the new memory technologies called non-volatile memory. Non-volatile memory is also known as persistent memory. Non-volatile memory, as the name implies, is a non-volatile memory that retains data even after the server is turned off. Non-volatile memory can be accessed in byte units, and in terms of performance and capacity, it is intermediate between DRAM, which is used for main memory in servers, and SSD, which is used for auxiliary memory in servers. In terms of performance, non-volatile memory has higher I/O performance than SSD and lower I/O performance than DRAM. In terms of capacity, non-volatile memory has a smaller capacity than SSD and a larger capacity than DRAM. Next, an overview of the CXL memory pool is as follows. CXL stands for Compute Express Link, an open standard for connecting devices such as CPU, GPUs, and other accelerators, network interface cards, and memory, and other devices. The CXL standard version 2.0 makes it possible to pool memory and share the memory pool among multiple hosts. For example, as shown in the figure on the right of this slide, it is possible to create a huge memory pool via CXL 2.0 compliance switch and then allocate memory to each host from the pool. By sharing a large memory pool with multiple hosts, it is possible to improve the efficiency of memory resource utilization. Many CXL-compatible CPU and memory devices are still in the sample stage and are not yet in full-scale production, but some device vendors have indicated their intention to begin volume production in the near future. Next, I'd like to introduce RDMA, a high-speed network technology, and RoCE, which performs RDMA on Ethernet network. RDMA stands for Remote Direct Memory Access, a technology that writes and reads data with low latency from an I/O source machine called an initiator to memory on a remote machine called target. RDMA RoCE does not copy data from the user space memory where the data is located to the kernel space. That is, it can transfer data in a form called zero copy. This allows data transfer and synchronization between the initiator and target with extremely low latency depending on the distance. RDMA RoCE is mainly used in the field of HPC, which is the abbreviation of high performance computing, but it is also used for data synchronization in the field of database and between non-volatile memories as well. In the last part of this session, new storage solution emerging to support new storage devices are introduced. Recently, non-volatile memory and NVMe SSDs, these new storages are enabled by new storage solutions. These solutions are available as software-defined storage and hardware appliances and used to accelerate HPC and AI workload. On such new storage solution is storage-defined storage known as DEOS. DEOS is optimized for implementation to take advantage of high speed of non-volatile memory and NVMe SSDs and can issue I/O to storage nodes running in DEOS and to the storage node running DEOS, the POSIX API or MPIs to achieve low latency and high throughput by issuing I/O.
以上が That is actually how we could realize faster in a stable and more scalable data platform, and that's what we were trying to do as a new landscape hardware technologies. Now, as previously introduced, taking advantage of the new landscape in hardware technologies, we would like to introduce a jointly develop and research between the Yahoo and Line using the MySQL unique storage engine. As a joint auditing theme, we research, develop, and implement MySQL Storage Engine architecture with which we can make the most of high-speed, non-volatile memory as new memory hierarchy for database. Specifically, we deploy log file to guarantee atomic of a transition, non-volatile memory, heap files, including data in database, index data, then access them by byte granularity. In addition, database is the infrastructure for multiple internet services. We should keep internet service processing despite a database node outage or fault. So leveraging is the feature of non-volatile memory, we implement a feature to realize fault tolerance. To be specific, from source node of MySQL responding to initiator, we transfer log to replica node tied to target when transition is committed. By doing so, leveraging the low latency of the non-volatile memory, and still we can synchronize the data between source and the replica. When the outage rise in a source node, switch to replica node for application to be connected to key processes, which enable us to provide non-interrupted internet service. Then, why do we need to implement our own storage engine for non-volatile memory? Why can't we use InnoDB default storage engine for MySQL and run it on NVM? Here are two charts. So these charts representing the machine implemented with the non-volatile memory, and a concurrent writing is done at the 10 threads with the I/O throughput. In terms of the hardware spec, I/O throughput theoretically is 22.2 gigabyte per sec. To your left, which says conventional file access. This is actually on the non-volatile memory, and the InnoDB is run on the non-volatile memory. With this solution, there's only less than 24% of the theoretical threshold, which means that 5 gigabyte per sec is the I/O throughput performance. On the other hand, non-InnoDB access solution, which means that like optimized way of non-volatile memory using our own access, which is represented by the chart on the right. In this case, the number goes beyond 70% of the theoretical threshold, which means that 15 gigabyte per sec I/O throughput was realized. So as a result of that, in order to take advantage of the non-volatile memory, we need to optimize in our own way to access to the non-volatile memory from the storage engine. This is exactly the reason why we dedicated ourselves to the development of our own storage engine. we just talked about our own joint R&D of the own storage engines responding to the fast network and new memory hierarchy. If we're going to use such technologies on the actual service, then the operation-related technological development is also important. And then such technological development has been done jointly as well. The example of the joint development for the operational technology is that the development of the backup and the restoring features for the management. InnoDB, which is a MySQL default storage engine, and then with the existing tool, and we can obtain the full backup, differential backup. On the other hand, with our own storage engine, since the record and the page formats are different from the InnoDB's ones, we haven't been able to obtain the differential backup nor the incremental backup. Therefore, we jointly develop a process to obtain differential and incremental backup for our own storage and implement them on object storage compatible with NAS and S3. Also, using such backup data, we provide a feature to restore data at any place you want. What I just explained was on the assumption that all the data are deployed on non-volatile memory. But what about in a case if we want to use more data than the available data on the non-volatile memory? We've been working on that to address this issue. And that exactly tied back to one of the new storage solution, DAOS, integrated with our own storage engine. To be specific, we isolate the storage space called the pool from DAOS cluster, and then isolated space is going to be shared, consisting of the MySQL source and a replica. So if we can use this pool as a table space for the storage engine, and then we can actually use more capacity than the non-volatile memory's available capacity. Already isolated DAOS and pool capacity gets down. If that's the case, if we can expand the capacity of the DAOS pool size online, then eventually that would expand the online storage accordingly. This kind of the shared disk architecture structures feature development has been jointly done. For your reference, let me quickly walk you through the overview of DAOS. DAOS stands for Distributed Asynchronous Object Storage. DAOS is a OSS software-defined solution for the major hardware vendors' development done. So as I introduced at the initial session, DAOS is optimized to the new hardware such as non-volatile memory or NVMe, SSD. So the major use case of DAOS includes the HPC or AI workload fast feeding. To the right on the slide is the diagram of the DAOS internal architecture overview. DAOS cluster is comprised of multiple nodes, and also MESSD of the non-volatile memory is managed by the theoretical unit called target. When we create a pool, we designate which target we should choose for that pool. For example, if we want to create a pool with a small amount of the DAOs, we just use 2 targets to make it happen. If we want to have like a larger DAOs pool, then we can actually choose the 3, 4, 5, or even a greater number of the targets to make a pool. So that would push up the initial capacity of the pool. So whenever you want to expand and increase the capacity of a pool, just adding the new target into the pool, and that will allow you to expand the capacity. DAOs and our unique proprietary developed storage and then the integration, there are multiple ways or multiple choices. The first choice is the integration using Fuse. So here the DAOs pool is mounted on a source node and a replica nodes on the Fuse basis, so that will allow you to issue the POSIX IO. And here you can access to the DAOs pool through the POSIX IO, so that other than the DAO still in another environment, still you can actually access to the storage engine. So it's good at portability. On the other hand, with this solution, Fuse daemon needs to convert a POSIX IO to native API for DAOs, which requires overhead around a conversion-related performance. The second choice is Fuse, the same as the first choice. When you issue a request for the read-write to DAOs pool, use an optimized library to bypass kernel space, minimizing the overhead while maintaining portability, which is the second solution in this table. The third choice here is the direct issuance of the DAOs native API from Storage Engine. So performance-wise, this third choice is the best. However, other than the DAOs environment, the storage engine cannot be integrated, so it has to face the portability issue. So among the 3 choices, we chose the second choice from the performance and portability perspective, and we are implementing this integration of functions for the storage engine and DAOs. Last part, as a wrap-up, says just go game continue. So I would like to share the future direction of our joint R&D. So firstly, what we want to do is to dig deeper in terms of the integration with the scalable storage, such as the DAOs, using the latest hardware and solution, specifically the storage engine embedded multiple MySQL cluster to the DAOs, so that the scalable storage shared multi-tenancy is something we would like to proceed with. To make sure that we're not going to have a noisy neighbor among the multiple tenants, so that we would like to work on the fine management of the performance isolation in QoS. The second one, we would like to proceed with further the discussion on the structure of the holistic management, integrating the scalable storage in a MySQL cluster for these more stable and secure integrated management and operation. Thirdly, and then looking into the integration with the scalable storage other than the DAOs, so that we would like to think about the storage engines more like versatility and a compatibility with other storages. Here is more like a future direction, we're aiming at R&D with focus on the CXL memory and memory pooling compatibility. Sharing the massive CXL memory pool among multiple database clusters, we're looking for a feature to add memory online depend on online in line with actual memory usage. High performance required on a service should go with CX memory to have data in memory with higher buffer hitting rate to satisfy its high level performance. Also, depending on the memory capacity, we should be able to add memory to memory pool online as technology. So that comes to the end of the presentation. We, Yahoo Japan and Line, will go hand in hand to provide a better service, which motivate us to work on R&D for faster, more stable, and scalable data platform. Thank you very much for your time to join us.
Mr. Matsuura, thank you very much. And we have so-called plus talk, and based on the point that the person who is going to interview will ask some questions, as much as possible, we'd like to receive questions from you as well and have conversation. If you have any questions, please post your question from the right-hand side below. There's a question mark. And if you want to ask Tomoaki Oscar from Line is going to ask a question. Please introduce yourself briefly. I am working at the MySQL team for operating MySQL as well as automation at Line. My name is Otsuka. Mr. Otsuka, listening to this session, what other thing that you wondered? It was an excellent presentation. Thank you very much. High performance and scalable and highly scalable database you are researching, and specifically any performance indicator that you are aiming at or any product that you are looking for R&D. Talking about the performance indicator, the fastest in the world, that is the only answer that I can give. And the unique storage engine use case that I introduced is assuming OLTP or Internet Service Backend, online database processing, and also Internet service to data analysis and also the OLAP. These are two use cases that we are assuming. And for both use cases, we want to be the fastest in the world. Yes. And any product that you are comparing, well, we want to go beyond all the products. Excellent, very ambitious project, and I look forward to the result. At Line, the size is huge, so there's a horizontal sharding, the 3 horizontal shardings, and one is a few tens of shards in horizontally. And for scaling, the sharded operation is a challenge. So if it can be done with one single database, we appreciate. And for scalability, how much capacity are you going to deal with? Any goal? The minimum goal is, as was discussed at the previous session, the DWAS or MySQL v2, which is provided by Yahoo Japan, and we want to go beyond that performance. In terms of order, we'll want to go beyond the terabyte or more in terms of the scalability capacity. Thank you. Changing the subject. I have been engaged in MySQL operation for 5 years, and I am interested in storage engine. And I have developed simple things myself. As MySQL Storage Engine, do you have any reason why you are developing for MySQL Storage Engine? Well, the reason is mainly two. First, the technical reason. The MySQL architecture is for optimization or analysis of MySQL and also issuing IOs and managing transactions. So that is a storage engine. They're clearly separated. And the storage engine, a new hardware-enabled database implementation is the right fit for this product. And the other reason is Yahoo Japan's data platform has so many use cases on MySQL, and there are so many users. So the company places high priority on this platform, and we want to improve further, and we wanted to make a big impact. That's why we developed this. Thank you. And in the previous session at 9, huge MySQL is being operated. So we are looking forward to making use of it there, right? In addition, MySQL Storage Engine, I think it is additional comment that it was good that we implemented. And MySQL is in the data. Yahoo Japan's data platform is such an important product and also has long history. Therefore, members who are operating have high skills. And also the operation management assets such as metric monitoring and alerting. There are so many rich assets as well. And in order to make use of those assets for MySQL Storage Engine, we developed.
Thank you. I used to work on the storage engine, but it's going to be the lower than the 100 layer, which means then optimizer is the area that we can't really touch, but that could be the obstacle or it could be the bottleneck. Yeah. So the storage engine implemented, and if you think about the future, the maintenance, it's better to really close as in storage engine, and then the higher layers, the optimizers on the MySQL. Quite strong restrictions we were affected specifically, or developing use case, for example, the warp for the data analysis and executing the parallel processing. So the MySQL's optimizers, these are based on the single thread executions affected by this very strong restrictions. We are working on the parallel executions. So of course, the higher layer is something that we would like to work on. But if that's the case, then MySQL's open communities, the integration, it needs to be happening further. Otherwise, we cannot really put it into practice. Yes, the lower layers, yeah, for the operators and developers, we don't have to change the coding, and still newly developed MySQL is something we could continue to use. So for the optimizer and higher layers to be worked on, or these are the things that you would like to do in the future? Personally, yeah, of course, I would love to take that challenge. But when it comes to the production environment, and then providing the good internet service permanently to users, that is actually the very basic on a condition. So once I'm convinced that I could pull that off, then of course, yeah, I would like to take that challenge working on the higher layer. Yeah, and you said that you would like to become the world #1 with what you're developing, and quite a high expectation we have on you. What's your plan for the future, or what's your actually ambition in the future? So what we're doing, or what we are developing, is a cutting edge with very challenging attitudes infused into it, and we want to make them more like open, available as knowledge, to bring more momentum into the IT verticals together with the other engineers involved. So the overall direction in the OS data is something that we would like to pursue, but for the timeline and then the issue that we need to address are not yet identified clearly. But if it's going to be the OSS, I would like to encourage you to be a committer as well as the viewer today. Once it becomes the OSS, appreciate your contribution to the OSS. Well, time-wise, this should be the last question. Can I ask one more question? We received some questions from the viewers. How many people are deployed for management? So this question is more for the operation. So in case in line, we have dozens people, less than 20 people are in charge of the management. How many people are deployed for the management? Well, Yahoo MySQL team size is similar to yours. Slightly over 10 people are in charge of the management, taking care of the couple of thousand in MySQL. So